Yes, dear students, actually till now I kept on telling you about uh, internal energy worked by thermal system and application of first law of thermodynamics. Internal energy, I told you, is the sum of uh, total energy, so sum of energy possessed by molecule of system. Now our system may be a solid, may be liquid, may be gas. So I told you something about internal energy, but now we will consider how much energy possessed by system and how many ways are there in which a particle can possess internal energy. So internal energy of a bulk system is the sum of its sum of its total energy possessed by all molecules. So that we have discussed. I have written only just these topics are related with internal energy. So now we come to the topic degree of freedom. So what is degree of freedom? First of all, I come to degree of freedom. So the degree of freedom of a particle may be defined as the number of independent motions in which the particle can possess energy or the degree of freedom may be defined as the number of independent ways in which a particle can possess energy. So number of ways, number of motions in which particle can possess or exchange energy is called degree of freedom. I told you our thermal system may be solid, may be liquid, may be a gas. In case of gases, first I come here to tell you about the degree of freedom of molecule of gases. In case of monoatomic gases, Which gas is called monoatomic? The gas whose one molecule, sorry, one molecule can possess only one atom, like helium, neon, argon, krypton. All inert gases are monoatomic. The gas whose molecule has only one atom is called monoatomic. In case of monoatomic gases, a molecule can have linear motions along x, y and z axes as shown in figure 1. As shown in figure 1. So, degree of freedom of monoatomic gas is 3. For monoatomic gas, degree of freedom is 3. For diatomic molecule, as shown in figure 2, this is the diatomic molecule. There is some distance between the atoms. The molecule of gas which has 2 atoms is called diatomic molecule. So it can have linear motion along x, y and z axes. This molecule as a whole can move this way and this way. And it can rotate about an axis perpendicular to the length of the dipole, molecule, like this, or about the axis. But moment of inertia, actually rotation kind energy, half I omega square. So here, moment of inertia about this axis is very small. So the amount of energy possessed this way is really small. So I can say here for diatomic gases, for diatomic gases, molecule is supposed to behave like a dumbbell, as shown in figure 2. As shown in figure 2, there is little trouble of noise, but I can't help if you don't understand. So, the molecule can have linear motions along x, y and z axes and rotatory motions about axes which are normal to its length and also about its own axis, but the moment of inertia is very small, about its own axis. Hence, kinetic energy of rotation about its own axis is negligible. Hence, degree of freedom of diatomic gas is 3 plus 2 equal to 5. 3 the motion along x, y, z axis, and 2 about rotatory motion. Now, in case of triatomic gas or any polyatomic gas, the molecule can have motion along x, y, z axis. It can have energy about acceleration for triatomic or polyatomic gases. The 3 degrees of freedom are there due to linear motion about 3 axes and 3 degrees of freedom due to rotational motion. About the 3 axes at high temperature. The molecules can have sufficient energy due to oscillatory motion. Of molecules about their position. So, at low temperature, degree of freedom for poly means many, polyatomic means many atomic, polyatomic gases is 6, but at high temperature it may be taken as 7. So this is something degree of freedom of gases like polyatomic like H2S, H2O gas forming. In case of liquids, again molecule can have energy due to rotational motion, but liquids, molecule is not more monoatomic. Generally, by these monatomic gases can be liquefied at very low temperature. So, like water in liquid state have energy, can move along XYZ axis, can rotate. So it may be taken like having 5 degrees of freedom. In solids, the energy possessed will be in the form of vibratory motion as well as due to leaf motion. And second is potential energy because of force of attraction. So for solids, the degree of freedom is taken as 2. I will discuss it later on also. Now here, so what is law of equipartition of energy? I will take it here and then apply it to different system. We have defined specific heat, molecular heat, gram molecular specific heat and simple specific heat when the mass of the substance measured in gram or kilogram. So what the statement of law of equipartition of energy. Here some new names come to you. I will be telling here. According to this law, the energy possessed by a particle is 1/2 kBt per degree of freedom. Half kBt. What is kB? Actually, kB equal to R by N. These two more names are there. Kb is called Boltzmann constant. Kb is called Boltzmann constant, and Kb equal to R by N. R is universal gas constant. You might have heard in chemistry. I will be taking later on, and its value 8.31 joule per mole. Here N Avogadro number. You know it is equal to 6.023 10^23 per mole. So kind energy possessed per degree of freedom per particle is 1/2 kBt. In next video I will be taking here calculation of total energy of gases, and calculating the molar heat of gases. Thank you.